Maxima and minima of differential equation. This is my new topic. What is maxima and minima of differential equation? What is that? Maxima and minima are the largest and the smallest value of a function either within the local domain or the entire domain of the function. The words maxima and minima means the maximum and minimum points of a function. There are some maximum and minimum points of a function either within the local domain or the entire domain of the function. Let me identify the maximum and minimum points of a function geometrically. Let me draw a graph here. It's the x-axis and here is the y-axis. This is my function f of x. It is the geometrical or graphical representation of the maximum and minimum points. Look to the function f of x. There are some maximum points and some minimum points. These are the points within the local domain. How to know that these are maximum and minimum points? Because when I draw the tangent lines on minimum and maximum points, they come straight along x-axis. So when the tangent line is straight along x-axis, it is the maximum or minimum point. Look at these two regions. The value goes from minimum to maximum. It is increasing till to the top. And when it crosses the top, the value again comes down. It is decreasing from maximum to minimum. In between, there is a point, which is the maximum point. When I draw a tangent line on this point, it comes straight along x-axis. That's why it is the maximum point. Let me connect with the x-axis and name it x1. Similarly, look to these two regions. The value goes down and it comes from maximum to minimum until to the lowest point. And then it goes up from minimum to maximum point. In between there is a point, which is the minimum point. When I draw a tangent line, it comes straight along x-axis. So this is my minimum point. Let me connect with the x-axis and name it x2. Again, check these two regions. The value goes from minimum to maximum. It is increasing till to the top and then goes down, which is decreasing from maximum to minimum. And this is the point, which is the maximum point. Draw a tangent line. It is straight along x-axis. Connect it with the x-axis and name it x3. Repeat the same process for the other points. Which is my x4. The same goes for the other point, for the maximum point, which is my x5. And for the other minimum point, which is my x6. And the last one, which is also a maximum point, x7. That's how we identify the maximum and minimum points of a function geometrically. x1, x3, x5, and x7. These are the maximum points within the local domain. Similarly, I have minimum points at x2, x4, and x6. These are the minimum points within the local domain. Let me consider the entire domain, the whole function of f of x. You're going to choose the highest value and the lowest value among all these maximum and minimum points. So the highest point is here, which is x1, and the lowest point is here, which is x6. These are the maximum and minimum points in the entire domain. I repeat it, we have maximum and minimum values within the local domain because of the curve of a function f of x. Sometimes it goes up and sometimes it goes down and then up and then down. But when you look to the overall function, I have one maximum point, which is x1, and one lowest point, which is x6. That's how the maximum and minimum points look like geometrically.